Okay, guys, so lesson P.1 is real numbers. If you look at the objectives over there, you'll notice there's several things. Convert between decimals and fractions, write inequalities, look at properties of algebra, work with exponents, scientific notation. It's kind of got a lot of miscellaneous stuff in it. Various forms of review here. So, as we start here, I think like all my classes start with this in their first lesson. Number systems. Let's go back and review. Okay, when I say a real number, what's a real number? Whole number, integer, natural numbers. What are all of these? Okay, so real numbers. Thoughts? Everything's real except what did we learn last year in Algebra 2? Imaginary. Okay, so real numbers are all the numbers we deal with the exception of imaginaries. I have it written in my notes as any number that can be written as a decimal. Okay, but it's not imaginary. So however you want to put that in your notes is kind of up to you there. I'm going to say any number that can be written as a decimal. Whoops, I can't spell already. Not a good way to start. And if I'm also going to say right up above, not imaginary. So anything not imaginary. Now, tell me, how are we doing on C? Can we see that colored pen? Can we see that writing? Do I need to put the blinds the rest of the way down, or are we good as is? You probably have a glare, right at the top of the screen, and then once I get down past it, you'll be fine.
Yeah, it's like eliminating the line completely once.
Or if I do something like that, maybe.
Yeah.
I just have to think about it, so yeah. And you guys know me. If ever there's something you can't see, read, for whatever reason, speak up and tell me, and we'll adjust somehow or another. I didn't put those blinds all the way down. I can if I need to. But I think the glare I was seeing was coming more from the overhead lights than outside. So, okay, so real numbers. Everything we work with the exception of imaginary numbers. Up until last year, it was everything you knew. Okay, rational numbers. Remember the definition of rational? Yep, everything that can be written as a fraction, or a lot of times you'll see the official terminology as a ratio. I like fraction too, don't get me wrong there, but anything can be written or expressed as a fraction or ratio. You guys know, do I need to remind you, that's not hashtag I'm using, that's a number sign, right? Just making sure. I know, I'm old-fashioned when I use that as a number sign, but gotta make sure. So, I'm going to say a number that can be expressed as a fraction or ratio. You will usually see it as in a definition like A over B, where B cannot equal 0. We would say B cannot equal 0 because denominators can't be 0, right? Okay, so real numbers are everything. Rational numbers is a subcategory, right? So all rational numbers are real. What are integers? This is an important one to know, because if you see a word problem that says, integer, uses the word integers. What are integers? Do you remember anything? Jacob?
They're all whole numbers. They can be either negative or positive.
Okay, whole numbers are positive thing. Now, officially, we haven't defined whole numbers, but you guys know what whole numbers generally, you know the idea of a whole number, right? He's indicating not a fraction or a decimal portion, right? So positive or negative. what I do is, okay, dot, 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 -3, -2, -1, don't forget 0, 1, 2, 3, dot, dot, dot. Does that give you guys a good enough idea? I like, even though we shouldn't officially use the word whole numbers, I agree. It's the negative and positive whole numbers and 0. No fraction pieces, no decimal pieces. Has to be equivalent to a negative or positive whole number. Okay? What are our natural numbers? There's another word that I use sometimes here for them. Sometimes hear them called the counting numbers. Preschool, kindergarten, you might call them the counting numbers. How do you count? Starting with 1, yes? If you're a kindergartner, you start counting at 1. Okay, so counting numbers or natural numbers start at 1. They no 0, no negative, just 1, 2, 3, 4, so on and so forth. Those are your natural numbers, also called the counting numbers. Okay, so what's different then with whole numbers? What makes the difference with a whole number? It can't be negative, but it can be 0. If it's negative, that falls back in integers. Whole numbers have to be positive. The only difference is they start at 0. So 0, 1, 2, 3, 4, so on and so forth. Oops. And we don't call those the counting numbers because as a little kid, you don't start counting at 0, right? Even though 0 is like one of the easiest numbers, 0 doesn't really exist when you're a little kid. So, okay, and that takes us to irrational numbers. What do irrational numbers look like? Pi. So why is pi an irrational number? Never ending and doesn't repeat. Okay, so officially our definition of irrational numbers, it's the opposite of rational. Rational is anything that can be expressed as a fraction. Irrational is everything that cannot be expressed as a fraction, except what does that really mean? So that's when we usually say decimals that do not terminate and do not repeat. So decimals that do not terminate. You guys know what it means to terminate, right? They do not end, do not terminate, or repeat. Natalie's example of pi is a classic example, right? What are other good examples of irrational numbers? There's one other type of number we use a lot.
Is it like that log, like the 10 log, whatever that one is?
Well, there's the e,
Yeah.
the natural number e, which was at 2.718 whatever. But besides pi and e, there's another good one, or another type of numbers. Square root of what is irrational? There's right and wrong answers here. Square root of a negative would take us to imaginary. And we're only talking real here. What was the other thing I heard? Depends on what even number you're going to tell me. For instance, if you tell me square root of 4, I'm going to veto. Square root of 4 falls into rational. Because square root of 4 is 2, which can be written as 2 over 1, which can be written as a fraction. But square root of what? How about square root of 3? Square root of 2 would work also, yes. Square root of 5. square root of 8, square root of 7, square root of 9? No, because square root of 9 is 3. That's a whole number. Okay? So irrational numbers, those big, long, messy decimals is a good way to put it. Not a mathematical way to put it, but it's a good way to put it. Big, long, messy decimals, right? Okay, those words kind of coming back to you a little bit. I mean, that's just my goal right there, is to refresh your memory about some of those words, because those words will randomly appear in math. And if you don't know what they mean, it makes the math a little more confusing. Okay, types of decimals. 2 types of decimals to talk about. Terminating decimals and repeating decimals. What's it mean to terminate again? To end. So it's if a terminating decimal is a decimal that ends. Let's see. For example, what if I say that 7/4 is a terminating decimal? Agree or disagree? Agree. Why? Because it ends. What is it?
1.75.
Yeah, 1.75. When I say 7/4, my brain, I don't know, maybe I go the long way. My brain says, oh, well, that's 1 3/4. But hopefully if you've made it to pre-cal, you then know that's 1.75, right? Notice I threw one out there that you should have been able to work with. You should have known. When I say 7/4, oh yeah, 1 3/4, 1.75. Okay, so that's a terminating decimal. It has an ending point, right? It has a set number of digits. As opposed to a repeating decimal, goes on and on forever and ever, right? What if I throw 4/11ths at you? Is that when you know? Not necessarily.
No,
Okay. That's not what I'm expecting you to know, I'll be honest. If you're sitting there thinking, oh, crud, was I supposed to know that one? No. 4/11ths is not one you have to know. How do we figure out what it is if we don't know what that decimal is? Calculator, what do you do on the calculator? 4 divided by 11. What's 4 divided by 11 tell me?
0.36.
Yeah.
Just 4.
Okay, so that's your calculator rounding. It's, you know, if it's saying 36, 36, 36, but then at some point instead of a 3 it plops a 4 on there, that's your calculator rounding. You can, though, safely, well, I don't know, I guess because I see a denominator of 11, things like denominators of 9s, 11s, those tend to repeat. So that is a repeater. Okay, so just as I said, a little bit more vocabulary there. Stop me if you need to slow down about something. So far, should be pretty easy stuff. Okay. Interval notation. I'm trying to remember, I'm spacing right now, how much we did in Algebra 1 and Algebra 2. I guess I should say specifically Algebra 2. And I think this is something that some places start in Algebra 2. I don't start it until pre-cal. Did we work with parentheses and brackets as endpoints instead of using open and closed circles? I don't think we did. Okay. And I think that's one of those things that they're going to say that we should have learned it, but we don't introduce it in Algebra 2 here. So when we talk about a closed interval, or a closed interval, then we're talking about an interval that has endpoints that are closed, included. Okay, so in other words, where those endpoints are included and filled in. For reference sake, I'm going to call those A and B. As opposed to an open interval, what's different if the endpoints are open? If the endpoints are open, we use not filled in circles, and that indicates those points are not included. Now, if we're trying to talk inequality there, what's shaded? And if it's shaded in between, it's shaded what? Where it is above A, right? So greater than A, and to the left of B, so less than B. What do these circles make the difference of? Whether I use what with those less than and greater than signs. You understand what I'm asking there?
No.
Yeah, whether it's, So here it's to the right of A, it's greater than or equal to A because this point is filled in. Whereas here, the point is open, so we just say that it is greater than A. Does that ring some bells? Okay. Now, instead of writing it's shaded between, it's like an and statement, what we tend to do is we tend to say, okay, it's A less than or equal to X less than or equal to B. Take a moment and look at that. Make sure it makes sense to you. X less than or equal to B. Is that shaded less than or equal to B? Yes, that's shaded to the left of B. Over here, it's A less than or equal to X. But remember, you have to flip that around to read it. So then it's X greater than or equal to A, and that makes sense. So that's a way of showing, okay, my shading is between A and B. Down here on the other one, the only difference is that we don't use the equal to. Okay, that's the old news. That stuff should seem familiar. You know, knowing when to use the less than equal to, when to just use less than. Now, in pre-cal, we will talk about, instead of putting less than, using less than greater than to show to write our interval, we will use parentheses and brackets. So meaning, instead of at the end at A and B, putting either a closed or open circle, we'll either put parentheses or brackets. Let me show you the difference here. Okay, so we still have lines. The ends of these, or line segments, I should be proper here. The end of my line segments are still A and B. But in place of a closed circle, so if my endpoints are included, we use brackets. So when I use the word bracket, think like square parentheses. Does that make sense? Not curved, those are square. And you need to make sure they look square. I can't question them when it comes to grading something. As opposed to, if you would normally use an open circle, in other words, that endpoint is not included, we use parentheses. And those are the typical rounded parentheses you use. And so when we read interval notation, which if I recall correctly, yeah, we'll practice some of this on the backside. When we read interval notation, instead of using the less than greater than sign, so if we read this interval starts at A, comma, this interval ends at B. At A is included. It has a bracket. So we're going to say bracket, A, comma, it ends at B, and B is included, and so we use a bracket. And so that's not an ordered pair there. That's an interval. That's saying that, you know, from A to B. The difference here, if the endpoints are not included, is that we use parentheses. And as I said, we'll get to the backside when we're doing examples, and we'll talk about how all this goes together. Okay? As I said, we're doing a lot of review, but this is new, isn't it? So, it'll make you work. Let's see. The endpoints, what were the endpoints of all those segments I just used? Those endpoints were A and B, weren't they? Okay. You guys know what endpoint is, right? The end of a line, the end of a line segment, I should say. So there's not really a good way to define that. Okay. Bounded versus unbounded intervals. If something is bounded, that means it has endpoints. What was I just showing you above? Did these have endpoints? Yes, these have endpoints. These are bounded intervals. So a bounded interval is it can be a closed interval where the endpoints are included, or it can be an open interval, such as above. So for a bounded interval, I'm going to say any. Okay, ignore my spelling here. Wow. Any closed or open interval such as above. Okay, so such as the ones we just talked about. So bounded interval, it has endpoints on both ends, right? Has those stopping points. Unbounded interval means At least one way doesn't. Okay, so one way is going off to infinity. If you're going off to the right infinity, that would be what? That is a positive infinity. Okay, so if it's, x greater than 3, so we're going to the right, we're going to a positive infinity. Or, what if it goes off to the left? Instead of positive infinity, we're going to have to use negative infinity. So, for example, these were and statements I was working with, or I was demoing up above. If I show like an or statement here. You guys remember and or statements, right? It's been a bit. You've slept since then. If we have a situation such as this, where A and B are my points, so instead of numbers, I'm using letters. But this shading on A, if we talked in inequalities, we would say, okay, this is shading what? Less than A? Because there's a bracket here, that's like a closed-in circle, so we'd say less than or equal to A. Or X is to the right of B, we would say greater than B. I just realized I meant to make that a parenthesis there. Sorry. I just glanced at my notes again, and I usually make that a parenthesis just to show the difference. So that would be X greater than B. In other words, it's not equal to, it's just greater than. Now, to show that in interval notation, remember, we're using the parentheses and brackets. We live in America. We read left to right. Yes? So, what represents this left arrow? Where's this left arrow going? It's going off to the left, which is negative infinity. Infinities always use parentheses with them. Comma. Okay, so I'm tracking. Where does this shading stop? It stops at point A. And notice, what does point A have on it? A bracket. Okay. This is officially called interval notation. Okay, so we'll talk about using interval notation. Instead of using the word or, officially use a U when you're working with interval notation or set notation. The U stands for union, which is another way to say or. Then over here, this shading begins at where? Begins at B. B, though, is not included. It has a parenthesis. So parenthesis B, comma. Where does this shading end? It technically doesn't end, right? So we call that infinity. And infinities always use parentheses. Okay, so again, we'll practice with actual numbers. I know some of you are not liking me right now because I'm using A's and B's. But I'm just trying to show you guys a little bit of the information. And we'll work on the back side, okay? Okay, so get what you need there. And start looking down at the first set of examples. Determine if the following decimals repeat or terminate after finding the decimal form. Thoughts on 1/16? Terminates? Why do you say terminates? Because it ends? So what did you find out about 1/16? .0625. That ends, doesn't it? Okay. That clearly you get what? 4 decimal places on the calculator. And review, how did you get that 1/16 if you had a calculator available? 1 divided by 16. Can we do that basic item on our fancy calculator if you have it already? Okay. Okay. So, .0625, it ends. So what's the official word? We're going to say that this terminates. 55/27. Is that one you know off the top of your head?
Yeah.
1/16, I'm guessing. Maybe some of you knew. But 55/27, yeah, no. Okay, so what do we find out when we do 55 divided by 27? What do we get? 2.037, It appears it repeats, doesn't it? So do you know how to express that officially? Write out all your repeating decimals and then put a bar specifically over the digits that are repeating. In this case, it's all 3. And so that is an example of a decimal that repeats. Okay. So, pretty obvious on A, pretty obvious on B. Okay, what are you finding out on C? You don't know yet. It ends? What if I say that wasn't one of the choices, though? When he's like, I don't know then. Oh, I guess no, I take that back. It does. That is one of the choices, isn't it? Sorry. I forgot what my mind was going the other way. Okay, it ends. But does it fill your calculator screen?
Yeah.
And what do I usually say about decimals that fill your calculator screen? They probably keep going somehow or another, don't they? But do we have a way to see what's off of that calculator screen? Not an easy way. Okay, so what are your calculator screens saying? I know it's 0.0 something.
0.058823529.
Anyone go past 9? Okay, I think the graphers say 4. I don't know if it goes any farther past that. That's as far as I have written down. Occasionally you'll get some other random brand of calculator that'll go farther than that. So as it appears right now, it doesn't appear to be repeating, does it? But that fills your calculator screen, which I always teach as it keeps going. So, how would we figure out what it does past this point? I'll give you a hint. You don't like the answer. What method would we have to figure out what comes after this 4? Long division. Now, did I say we were going to use this method? I did not. So before you get mad at me and start stressing out, so you're like, oh, what? Okay. So here's what I'm going to tell you, and I'm going to tell you this. Hard to believe, but this is technically a repeating decimal. At some point, these digits start repeating. It's not your typical repeating, because when we think repeating, we think 1, 2, 3, some small amount of digits that you can see. This technically repeats. But in order to show that, we would have to do the long division. And we have better things to use our time for. So, just, don't just assume it terminates because, I get it. That's the logical answer, isn't it? It terminates. However, it keeps going. And it repeats via long division. So, I'm just... I'm not even going to write the repeating bar because I'm not 100% sure. Not 100% sure if it starts repeating right away or if it goes farther before it starts repeating. Okay.
First page done.
First page of notes done. Okay, so this kind of goes back to, I was trying to introduce a little bit of interval notation with the A's and B's on the front side, right? So this kind of goes back to that. We're going to use some numbers now instead and practice, how we do the interval notation, how we do the graphs, and all of that. So, describe and graph the interval of real numbers for the inequalities. First of all, what does that read? What is that in words? Okay, x is less than 3. We know which sign is which? That was the reason I asked that and didn't read it. Okay, so that is x is less than 3. What does that look like on a graph? There's my graph. I'm going to put on 1, 2, 3, 4, 5. I always say, obviously if it's x less than 3, 3 has to be on there. Yes? Maybe it's not obvious, but my brain's obvious. 3 has to be on there. And put a couple other numbers around it. Don't just put 3. I want to know that you know what numbers go on either side of it. How have we graphed this in the past? Okay, because it's x less than 3, we shade to the left of 3. And what do we traditionally put at 3? Huh?
It's just a dot.
Okay, which kind of dot?
A prudent dot.
Okay. Okay. Back in algebras, we put an open dot because it's not equal to 3. However, I'm not using dots. I don't want you guys using dots. We're going to use parentheses and brackets. So, 3 is not filled in. The equivalent to having an open circle or open dot is to use a parenthesis. Your parenthesis curves in to the direction of shading. So that is equivalent to saying x less than 3. Okay. In words, because it did say describe, and describe traditionally means using words. So if we said it's less than 3, right? So it's all numbers that are less than 3. Instead of using the word all, though, I'm going to say about real numbers. Real numbers less than 3. That's my description there. To practice. This is I was just rereading the directions and making sure. We've done what we were supposed to do here. We described, which described to me says use words, and graphed it. We graphed it, yes? Okay. This is what I would call an inequality. It uses a less than or greater than sign. How do we write this with interval notation? Okay, so interval notation says, look at your graph. Where does the shading begin here? Where does my shading begin? What do we call this? Is that a number that my shading begins at? Does it begin at a specific number? Let me ask it that way. No, it doesn't begin at a specific number. What represents when it goes off to the left indefinitely? That is a what?
A negative infinity.
Yeah, a negative infinity. So when we're doing this in interval notation, it's starting at negative infinity. Negative infinity and positive infinity always use parentheses, comma. Where's the other end of this shading at? It's at 3. And am I using a parenthesis or a bracket with that? Parenthesis, because 3 was not included. That's how you write interval notation. Okay? When we get to homework, I want everything written in interval notation. I don't remember exactly how the directions read. I have to look back at that. But I want everything written in interval notation. That's what we need to practice. Because that's what we pretty much do throughout pre-calc. Okay, questions before I try B? Okay, let's try B. When I read this, I'm going to read this as negative 1 is less than x is less than or equal to 4. I'm going to go ahead and put my number line down here. And I'm going to say negative 2, negative 1, 0, 1, 2, 3, 4, 5. 5. You can maybe number by 2s or I don't know, do something, but you gotta have a -1 and a 4 on there at least, yes? Thoughts on what this means? What does -1 less than x less than or equal to 4 mean? Where is that shading? Okay, between -1 and 4. Because right there, guys, x less than 4, that means from 4 we are going to go to the left, correct? But this, -1 less than x, reverse it, it's x greater than -1, so you're between -1 and 4. Now, what do we need on -1 and on 4? What do we need on -1? Parenthesis. It's like an open circle, right? But we're going to use a parenthesis. Now, my parenthesis goes the other way this time because it's the shading is inside the parenthesis. Is that a good way to put it?
Yeah.
I don't know how to put it in words. What goes on 4?
Bracket.
The bracket because it's included. Good. Okay. If we put this in interval notation, now that you have the graph, interval notation is real easy. Where does my shading start? -1, and what's at -1? Parenthesis, comma, where does my shading end? 4. What's at 4? A bracket. There's your interval notation practice. Now, officially I need to use words and describe. Where did we shade? Right, between -1 and 4. So this is all real numbers between -1 and 4. If I get particular, as I should, it's all real numbers between -1 and 4. We need to address those endpoints. It's excluding -1, right? So we can just say all, but then what's it do with 4? It's including 4. So I'm going to state that this is excluding -1 and including 4. So I said all real numbers between -1 and 4, excluding -1 and including 4. If both endpoints were parentheses, you could just say all real numbers between -1 and 4. If both endpoints were brackets, we could say all real numbers between -1 and 4, including the endpoints, or including -1 and 4. So you have to address that. Feeling a little more comfortable with that? A little bit, maybe? Okay, let's see. Where am I at here? See if we have time for A here. Write an interval of real numbers using an inequality and draw the graph of the following. Now, I'll be honest, we'll probably practice interval notation here too, but okay, so we're kind of reversing what we did last time. The real numbers between -4 and -5/10. You can either tell me what the inequality looks like there, or you can tell me what the graph looks like there. Thoughts? Parentheses. So if we talk about the graph here, let's see. -5, -4, -3, -2, -1, 0, 1, 2. What was I going to? Oh, I was only going to -0.5. Whoops. Oh, well. It's going to be a -0.5 there. Okay. Natalie said parentheses. How do we know parentheses? Not because they're negative. It just says the real numbers between -4 and -5/10. Does it say anything about including those? No. So you're going to use parentheses because it's just the real numbers between there. And so where am I shading then? Shading between? Something like that. Can you guys see what I wrote there? See if I zoom in a little bit. Now, do we know what that looks like as an inequality? Here's my hint. Go up and reverse what we did up above. This is real numbers between two numbers. What would that look like as an inequality up above? X in the middle. So we can say, if I put X in the middle, bigger number on the right, so -5/10 on the right, smaller number on the left, -4 on the left. It's going to be less than -5/10, so we use the less than symbol there. It's greater than -4, but this is reversed. So I'm going to say -4 less than X less than -5/10. That would be your inequality. You know what to write as interval notation? Again, it didn't ask for it, but interval notation, where's the shading start? -4 with a parenthesis, ends at -5/10 with a parenthesis. Okay, I think we have to stop there, don't we? Yes. So, we will pick up there tomorrow. You can copy the homework down and get started. You can wait. I will say, anything that deals with inequalities, we're going to be using interval notation. I don't remember how the directions read, but I want interval notation. Okay? I will double check. I don't know, maybe I'm